Alright guys, so today we are talking about distance, midpoint, and de Moivre, his theorem, all these things. Okay, so we want to multiply this complex number. Remember, it's a plus bi, and we're doing that to the third power. Okay, so if you remember our formula from yesterday, we did the polar form, and that's what you need for de Moivre. Okay, so the polar form was z equals r times cosine of theta and I times sine of theta. Okay, but now we're going to change it a tiny bit because we actually have an exponent on this guy. So what we're going to do is we're basically going to distribute this exponent to all of the things on the inside, but it looks a little bit different when we get to our sine and cosine. So de Moivre says that we have r to the n power, whatever our exponent is, and then we're going to multiply by cosine, and then it's n times our theta, and I times sine, and then again n times the theta. So we need to figure out our r and our theta, and then we're just going to multiply by n through it. Okay, so let's look at A. So this guy, we have to figure out our r first. So remember, that's the square root of -1 squared, and this guy, our b value squared. Whew. So we have the square root of -1 squared and the square root of 3 squared. Whoops, heavens. What happened here? Delete. Okay, go back. There we go, parentheses squared. There we go, like that. Oh, What happened? Oh. I think that's okay. There we go. Okay, so r is 2. And then remember to figure out your theta. It's the inverse of tan, where your b value is over your a value. And since our a is less than 0, we're going to add 180 degrees to our theta. So we're going to do the inverse of tan, the inverse of tan, and then I like to use a fraction-y button and put the square root of 3 on the top, -1 on the bottom, and then add 180, and we get 120. So theta is equal to 120. Okay, so now we are going to deal with our cube. So when we set this up, it will be, so it's just like we did yesterday, but we're going to put the exponent on and then multiply the exponent in front of your theta. So it's going to be 2 cubed times cosine of 3 times 120, and I sine 3 times 120, like that. So we're going to do each piece at a time. That way we can figure out their exact value. So 2 cubed is 8, and 3 times 120 is 360. So then we have cosine of 360, and I sine of 360. Okay, so now we're going to actually do this because we want our complex numbers, okay? So we have, what we're going to do is distribute that 8 through, just like we did before. Okay, so we're going to do 8 times cosine of 360, wow, and then 8 times sine of 360. Okay, so that's what I'm typing in my calculator. 8 times cosine of 360 is 8, so we have 8, and 8 times sine of 360 is 0, so that would be 0i. So that is de Moivre, and it just basically helps you distribute that cube to all of your imaginary and real pieces on the inside. Okay, so we can do one more. So this guy, the first thing we're going to do is figure out what our r value is. So that is -square root of 3 squared and 1 squared. So we have the square root of negative square root of 3 squared and 1 squared, and that is 2. So r is 2. That's basically like the same thing as before. Okay, and then our tan will be 1 over negative root 3. And since negative root 3 is below 0, we have to add an additional 180 degrees. So the inverse of tan, fraction button, 1 over negative root 3 equals negative 30 plus 180 is 150. Okay, so theta is 150. So the same idea here. So we have 2 to the 8th power times cosine of 8 times 150 and I sine times 8 times 150, and then we are going to simplify. So 2 to the 8th is 256, so we have 256, and then it'll be cosine of whatever 8 times 150 is, which is 1200, and I sine of 1200. Okay, so then again we distribute 3 through, so 256 times cosine of 1200 is negative 128, and 256 times sine of 1200 is, a decimal, which is fine, we'll just write it down. 221.7, and there's an I, so that's my complex number. Okay, and that's how you do de Moivre. And I will do another video on distance and midpoint of complex numbers. Have a great day. Bye.